Hello everyone, let's take a look at our next problem. Compute the integral of the square root of x squared minus 1 over x dx from 1 to 2. So I'm thinking maybe there's a substitution. Maybe I bring the x into the square root, the 1 over x into the square root. I'm not sure. Again, I noticed the thing under the square root sign can be written as a difference of squares. Will that help? I don't know. Okay, let's let's just see what happens if I bring the denominator under the square root sign. Does this make my life any easier? Doesn't really look like it. It almost looks a little bit like a problem I did recently with an exponential under the square root sign. I wonder if, I know this, this isn't directly the substitution you would normally want to make in this case, but maybe something comes out of this. So then what do I have here? I have dx is equal to du over 2x. So then my integral goes from 1 to 4 of u minus 1 divided by x times du over 2x, which gives me 1 over 2 u minus 1 over u du. Looks weird that these two things should be equal, actually. And does this help in any way? Maybe I'll come back to that. Maybe I'll come back. See if we can just look at the original problem in a different way. I almost feel like, again, there might be a trigonometric thing going on in the background here. What is going on? Get out of here. Or maybe I'm just going to try something and see what happens. So this looks like it does something, kind of. E to the u minus 1. Sorry, my bounds are going to change here. When x is 1, u is what, log of 1? No, I mean, goodness, 0, duh. And when x is 2, so I have 4 is equal to, so it's what, equal to log 4? Does this help? Wait a minute. No. Yeah, I did a question recently where we had to integrate this. I don't think don't directly see if that would help here. X squared minus 1. We could try integration by parts. It probably won't help, right? I can differentiate the numerator, integrate the denominator. That'll give me what we'll end up having to integrate. 1 over 2 x squared minus 1 to the negative 1 over 2 times 2x log x dx. Okay, I don't expect it to do much, but I'm going to do a slightly similar substitution to this one. Yeah, this doesn't do anything. What about a straight trig substitution? The problem here is I see that the bounds of x go from 1 to 2. So like if I go x, oh wait. What is the sine squared plus cos squared equals 1? Tan squared plus 1 is equal to secant squared. So tan squared is equal to secant squared minus 1. So I want x to be equal to secant u, then dx is equal to secant u tan u du. And now I have an integral from secant inverse 1 to secant inverse 2 of secant squared u minus 1 divided by secant u, and dx is secant u tan u du. Secant squared minus 1 is tan squared, so this becomes tan u secant squared, so tan squared u du. Do we have an antiderivative of tan squared? Okay. Of course. Tan squared is secant squared minus 1. And we know the antiderivative of secant squared. Sorry, so I don't need this. The antiderivative of secant squared is tan. So we have tan u evaluated from secant inverse 1 to secant inverse 2 minus, this difference, secant inverse 2 minus secant inverse 1. So the tangent of secant inverse of 2 minus the tangent of secant inverse of 1 minus secant inverse 2 plus secant inverse 1. I don't know if there's a nice simplification here. Like secant inverse 2 and secant inverse of 1. Do those have nice expressions? I'm not sure. I'm not really... I don't think I'm going to try and figure that out right now. I guess like the only part of me that thinks I need to check something is I would like to check that this was the correct antiderivative of everything. So if I substitute back what u is in terms of x, actually this is going to be a mess, right? Because I'm going to have the tangent of secant inverse. And I could just derive what the derivative of secant inverse is, but it's looking like I would need some other identities and so on. Let me just check this substitution quickly. So x is equal to secant u. This is correct. Derivative of secant is secant times tan. This is correct. So when x is 1, u is secant inverse 1, secant inverse 2, secant squared minus 1, secant tan, cancel, tan squared. I think this is correct. I'm going to give this my seal of approval at this point in time. And just hope I haven't made any stupid mistakes. Thanks for watching.